Okay, remember I said an AC circuit is mostly represented using a sine waveform. Now mathematically, instantaneous current in an AC is always given as I naught sine 2 pi f t. Let's call this one equation 1. So this is the formula giving the instantaneous current at every point in time. You see, so when you plot the value of the current against every point in time, you're going to get, using this formula, you're going to get the sine wave. If you plot it on a graph, you're going to get the sine wave, you see, which is what we treated a while ago. Now, in this case, this I here, where I is equal to instantaneous current, I naught is peak current.
Which one is here?
Of course, F is frequency of the AC source.
Yeah, that's by 0.
And then T is time. So I is instantaneous current. That is the value of the current at every point in time. I naught is peak current. F is frequency of the AC source. And T is time. So now, but remember that omega is equal to 2 pi f. So we call this one equation 2. Now if you put equation 2 into equation 1, putting 2 in 1, we have, so our instantaneous current
when there is a difference in GF
is equal to peak current sine omega t. You see, so the whole of this 2 pi f comes off and then replace it by omega, where omega is, in this case, omega is not okay, omega is angular frequency. Not angular velocity, please. You know, we are used to seeing omega to be angular velocity. That is what we're talking about, describing the motion of a particle in a circle.
Is there any difference?
When we are describing the motion of a particle in a circle, then this omega here could mean angular velocity. But when we're using it to describe an AC current, there's an alternating current, the omega is no longer velocity but angular frequency. You see?
Closing balance for match.
Okay, so let's say example 1. An alternating current.
Yeah, I agree with you, but unless I see it, I may not be able to
is given by the equation.
But
I is equal to 4 sine 10 pi 10 pi t. Find the following. 1. The peak current. 2. The angular frequency. Then 3, the frequency of the frequency of the AC source. Let me see. So
Is it balanced?
so an alternating current is given by I is equal to 4 sine 10 pi t. So find the peak current, the angular velocity, so the angular frequency, the frequency of the AC source. So this is a rather very simple question to solve. So what we're going to do is this. You know, an AC circuit, the instantaneous value of an alternating current is given as I naught sine 2 pi ft, or I equals I naught sine omega t. Now from the question, the alternating current was given as I is equal to 4 sine 10 pi t. Pi t. So what we're going to do now is just to take correspondence. We have to take correspondence here. Now if you look, to answer our first question, find the peak current, which is I naught. When you compare this equation to this equation, you see that I naught corresponds with 4. So our I naught is very easy to read it off. It gives us 4 ampere. Again, I naught means peak current.
Not it.
Now number 2. The angular frequency, which is omega. Remember I told you that omega is angular frequency. Okay. So omega here is, from here we can easily see that omega is the same thing as 2 pi f, and from here it corresponds to 10 pi. So we have 10 pi is our omega, 10 pi radians per second, or we can say omega is equal to 220 all over 7 radians per second. Any one of them is fine. The omega here corresponds to 10 pi, and that means omega is equal to 10 pi radians per second, or omega is equal to 220 over 7 radians per second. Of course, if you want to get a decimal here, of course you know how to divide it. You divide this by 7, you get your answer. And then number 3, the frequency of the AC source. Now remember that omega is equal to 2 pi ft. No, sorry, 2 pi f. Omega is 2 pi f. Now from here we have, okay, 10 pi is equal to 2 pi f. This pi will cancel this pi out, and then we have these two would take this 10 out, and so we now have f is equal to 5 hertz. That's our answer. That is, remember that omega is equal to 2 pi f. So to find our angular frequency, to find our frequency, the frequency of the source of the alternating current, we have to equate this to this. And of course from here we know that angular frequency is 10 pi, which is here, is equal to 2 pi f. So if you cancel this pi and this 1 out, take this 2 away from this, so divide 10 by 2, we get f is equal to 5 hertz. It's as simple as that.